So let's talk about line angle formulas. So line angle formulas are really important in organic chemistry because this is the way that you're going to represent molecules in both organic 1 and organic 2. And it's kind of a shorthand to what you've seen in Chem 1 and Chem 2. It just saves a lot of time. Then instead of having to draw out a bunch of C's and H's, you end up just drawing zigzags. So let's get into it. Okay, so a couple things to keep in mind. So first, you always are going to want to include lone pairs. And formal charges. Always pay attention to geometry. So this is kind of like the tetrahedral shape, or that's the most common one, trigonal planar. And a trick for this is anytime you have a straight chain carbon, it's going to be a zigzag. Are always zigzags. The only exception for this is if you have triple bonds. Or I should say triple bonded C's, which is, or a C or a cyanide, a C triple bonded to an N. So that will end up looking something like this. There's some carbons, but if you had a triple bond, it would end up looking something like this. So that's how you pay attention to geometry. That's the same thing with hybridization and that kind of deal. And then another very important point is hydrogen atoms directly connected to carbons. So H's directly connected to carbons are not drawn. So you can kind of see that here. But any other heteroatom and a heteroatom is just an atom that is not a carbon or hydrogen. And these must be included. That's really important to remember. And we'll talk about that. I'm going to do an example in just a second. And then another really, really important point is you never want to violate the Octet Rule. Oops. Never violate the Octet Rule. And the most common thing to avoid breaking the Octet Rule is don't draw a carbon with more than 4 bonds. So that's the most important thing to remember to avoid breaking the Octet Rule. So now let's do a quick example, just kind of how to go into drawing these formulas. So actually let me erase, we'll keep these up. So let's say we wanted to draw the line angle formula for, so draw line angle formula for okay, so a 3-step process to do this. I might end up having to move over onto this set, but we'll start with here. So we just draw the regular Lewis structure like you did in general chemistry. So I'm not going to go out and count out the number of lone pairs that there's going to be. I'm just going to look at how the atoms would be interconnected. So you've got this CH3 with it in parentheses with the 2. So that means there's 2 CH3 groups that are connected to the same atom. In this case, it's going to be this carbon. So I'm going to start by drawing this carbon here. And I know that has 2 CH3s connected to it. And it also, this has a hydrogen connected to it. And notice I'm ignoring the geometry to start. Then we go over and we have a CH2. C. All right, there's an O here. We're just going to leave that like that for now. And we have a C8. Oops, let me draw it out. We have a CH3 over here. Now you'll notice here that this carbon only has 3 bonds touching it. So we haven't exceeded the octet rule. We have less than the octet rule. So this would have some type of formal charge on it, and so would the oxygen if we left it like this. But notice over here that there's no formal charges in this molecule. So that means we have to add a double bond, another bond here to make this a double bonded oxygen. And that will complete the octet rule for this carbon and the oxygen. We have to draw in these lone pairs for the oxygen, again, to avoid having any type of formal charge. Okay, so we'll go to the second step now. Let's see, how do I want to do this? So we'll go ahead and draw it with the proper geometry now. So remember what I said over here, where if you have a straight chain, you're going to have the carbons in this zigzag. So in this situation here, our carbons are in a straight chain. There's no type of double bond between the carbons, or triple, but more specifically triple bonds between the carbons that might mess that up. So I'm just going to draw the same thing here. So I'll just count my carbons here, 1, 2, 3, 4, 5, and then I've got the 6th one down here, but I'll draw that in last. So I'll start with the carbons, and they're zigzag. So 1, 2, 3, 4, 5. And I'll label those again. Okay, so carbon 1, CH3. This carbon 2 had a CH3 down here, and a hydrogen up top. Carbon 3, they were just H's. 4, we had the oxygen. And 5, CH3. Okay, so we're almost there. All we have to do now is the third step, which is just erase all of the carbons and the hydrogens. So I'll write step 3 up here, and then I'm going to do it down here. Or actually, no, I'll do it up here so there's a little more space. So 3, erase C's and H's. So just real quick, the same thing I drew down there. Okay, so I'm going to erase, I'll start with by erasing these hydrogens. Okay, and now I'm going to erase the C's, and as I erase the C's, I'm just going to connect, because every time you see a point, every time you see a point like this is a carbon, so 1, 2, 3 carbons. So I'm just going to erase those and then connect. And I'm actually going to end up moving this guy up, because you're going to want to avoid drawing your your CC bonds kind of inside one of these hills. You want to always keep it on top. And there we go. That's the bond line, or the line angle formula for this, for this molecule. So you really want to make sure you get good at these so you can draw these really quickly. And you can see how much time it saves you. It's a lot faster to draw this, which is just a couple strokes of the pen, as opposed to taking the time to go out and draw all those C's and H's. So you'll want to do some practice. This is how you'll see it for the next 2 semesters. So you'll get really comfortable with it.